Hello. In the previous video, I defined the cumulative distribution function, CDF. Let me call it CDF. And CDF was defined this way. And I told you that I'm going to show you how to calculate probability given the CDF. So let's think about this example. I will consider x as a random variable that captures the amount of randomly ordered total-size coffee. So you ordered a total-size coffee from a random Starbucks, and then what is its exact amount? And I will simply assume that the CDF is given at 3 points. You have information about only at 3 points. So that is the probability that a total size coffee is smaller than 11.9 ounce is only 5%, right? By the way, of course, the probability is example. It has nothing to do with real probability from Starbucks. And the probability that cumulative probability that the amount is smaller than or equal to 12 ounce is 30%. So, and 90% probability lies below or equal to 12.2. So the probability, the amount is smaller than or equal to 12.2 ounce is 90%. So given these three information, the three are the given CDF, and we would like to find probability, the amount is greater than or equal to 12. Can you calculate that? Think about this. It's simple probability. So think about how you can calculate that probability. Pause the video and try to answer by yourself. I'll give you the answer. The answer is coming from this information. So remember, CDF is a cumulative probability. So f of 12 gives you the probability smaller than or equal to 12. Smaller than 12, but we are interested in greater than 12. Then it's complement of this. So 30% is smaller than 12, then obviously 7% would be greater than 12. The answer can be exactly considered this way. So a cumulative probability gives you smaller than x. So like say the value increases this way, and so smaller than 12 is this length in this area, in this interval, and we are interested in greater than x, that is this part. Then how can we tell this length using this? Because we know the total length is 100%. So I am treating probability as if length. Still there is no problem. So we know the total interval has its length is 100%, and this much is 30%. Then the other part is automatically 70%. That's how we obtain probability different from a cumulative probability. By the way, inequality does not matter whether you include 12 or not. Does not matter because 1 point has no probability. So including 12, so probability greater than 12 and probability greater than or equal to 12 are the same. Including 1 point does not make any change. So you can simply just consider and ignore the equality. So anyhow, it's intuitive, 70%, pretty simple. And I'll give you another question. What is, also given the same information, what is the probability that the amount is in between 11.9 ounce and 12.2 ounce? Think about the answer. Pause the video and answer by yourself. I'll tell you the answer. The answer is coming from the first CDF and the third CDF. So we know that, again, smaller than 11.9 is 5%. Smaller than 12.2 is 90%. Then, how we may understand them this way. So, we know that smaller up to from 0 to 12.2 is 90%, and from 0 to 11.9 is 5%. We are interested in between 11.9 and 12.2, right? So, put it this way, longer interval has 90%, and smaller interval, which is included in the longer interval, is only 5%. Then their difference is automatically 85%, which is the probability in between these two guys. Make sense? So again, it's a you may understand probability as a kind of length, right? So, and then it's easy. What is the length between 11.9 and 12.2? But what we know is length up to 12.2 and length up to 11.9 from 0. So their difference will give you the length in between those 2 points, which is 85%. This is how we use the CDF. As you can see, actually, so I only gave you 2 examples, but that's almost all you need. So cumulative probabilities. So cumulative probabilities are given. So if you know the cumulative probabilities, and then what you don't know is probability greater than something. So cumulative probability is probability smaller than something, which is known. And probability greater than something can be calculated this way. And then probability in between 2 points can be calculated this way. These 3 types of probabilities are what you need. There is no other probabilities. Of course, you can think about probabilities on multiple intervals. Then simply you can add the probabilities on each interval, like this. So as you see, knowing the CDF implies a lot. You can calculate any type of any probability of any type. So it will be pretty useful to know the CDF. That's the main point. Our next step is so summary up to this point is the CDF is what we need. That is the basis of distribution that contains full information about a random variable. That is the CDF. And so far, I have explained as if the probability can be understood as a length. It is not wrong, but it is just roughly speaking. It's roughly true, but not exactly true. Not rigorous enough to generalize to any cases. So this actually, the example we considered earlier is different. It is a contradiction to that assumption. So in our example, probability is not proportional. Think about this. The interval between 11.9 and 12 has 25%, and between 12 and 12.2 has 60%. But they are not proportional. The first interval and the second interval is twice larger than the first interval, but its probability is more than twice of the first probability, right? So put it this way, 25% lies in this interval, and 60% is more than twice of 25%. It lies between twice a larger interval. So it is an example, counterexample that in which the probability is not proportional to the length. So we have to expand our framework. I have explained as if the probability can be replaced by the length. but we are going to generalize it. The idea is this: we will increase the dimension, right? We will increase our dimension. So just in general, we can think about up to 3 dimensions, right? So 0 dimension is a point. So there is no measure. A point has no size, no measure, no amount. And in 1 dimension, a line, you have a line. Line is a dimension and its measure is length, right? And if you have 2 dimensions, then you can make a square, like it's a plane, and on a plane you can make a square, and on its measure of a square is its area. How big a square is, then it's measured by its area, which is calculated as the multiplication of width and height, right? You know how to calculate size of a square. And in the 3-dimensional space, an object is a cube, you know, like a dice, and its size is measured by its volume. Volume is 3-dimensional multiplication with height and depth. So 3 measures are multiplied. So far, I have explained the probability lives in a 1-dimensional space. No, but I am going to expand that concept into 2-dimensional space. So from now on, I will explain the probability is proportional to the area, not length. From now on, I will represent the probability by an area. So I'm going to do that in the next video. It will be interesting to how to generalize from 1 dimension to 2 dimensions. See you in the next one. Bye.